Okay, hello guys, welcome back. Um, Today we are going to do a numerical on lasers, and okay, let's check it out. Okay, so let's write what is given to us first. So it is given that the laser is of 10 milliwatt laser. So a 10 milliwatt laser, what can we understand from that? Uh, so it is saying that there is a laser and its specification is 10 milliwatt. So it can't be the name of the laser, right? Okay, if and we have to give the name, we would have called it ruby laser or HENE laser, helium neon laser, right? So what do you mean by 10 milliwatt? 10 milliwatt, see here, milliwatt is the unit of power. So it is actually, it has given you the power of the laser. So we can write that the power of laser is 10 milliwatt, and 10 milliwatt is 10 into 10 raised to power minus 3 watts. So power is given as 10 raised to power minus 2 watts. So this is the first information that was given. Okay, then it is saying that it contains 0.01 mole of neon gas. Okay, so amount that is given to us, amount given is 0.01 mole. Okay, so we know that in 1 mole we have 6.023 into 10 raised to power 23 atoms, right? So if there is 0.01 mole, so in 0.01 mole, the amount number of neon atoms will be 6.02 into 10 raised to power 23 into 0.01. So it would be number of neon atoms is given as 6.02 into 10 raised to power 21. Okay, this is the second information that is given to us. Okay, let me change the color. Okay, the question is what fraction of neon atoms? Okay, now it is asking that what is the fraction? Fraction of neon atom present in the tube participates in the laser process per second. Okay, so it is saying that what is the fraction of neon atoms which are taking part in laser action, means emitting light, in 1 second. So this is the third information that we have been given, and the fourth one is take lambda equals to 600 nanometers. So wavelength of the light is given as 600 nanometer. It means 600 into 10 to the power minus 9 meter, which means 6 into 10 raised to the power minus 7 meters. Okay, so this is the fourth information. Okay, so we have to find out the fraction of neon atom. So fraction, what do you mean by fraction? Fraction always means a number of events that we are interested in by total events. Okay, so what are the number of events that we are interested in? So we are interested in how many number of neon atoms are there. This is the total amount, right? Okay, so number of events or number of neon atoms which are taking part in emitting light. So number of events where are neon atoms taking part in laser action. It means how many neon atoms are uh, uh, getting from excited state to the ground state. So that is the number of events. This is we are interested in, and total number of neon atoms is given as this. Total neon atoms are given as 6 into 10 raised to power 21. Okay. So now our problem is how to get this thing, right? So we have to find out how many neon atoms are taking part in laser action. So there is one thing that you must know. When an electron jumps from metastable state to ground state, so this is metastable state, right? So if one electron comes down, it means one neon atom will come from metastable state to ground state. So this is the ground state. Okay, and when this happens, so I should color it. So when one electron jumps, one atom comes from metastable state to ground state. It means at that time one photon will be emitted. So what is the relation? Relation is when one atom comes from metastable state to ground state, it means one electron has jumped from metastable state to ground state, and at that time one photon will be emitted. It means number of photons should tell me number of atoms taking part in laser action, right? So the problem now has come to find out the number of photons that were being emitted. So how do you find number of photons? So number of photons can be found out from this formula, that total energy of laser by energy of one photon, right? So if there are 100 joule of energy or 100 electron volt of energy, and one photon has 1 electron volt of energy, then how many photons are there? Obviously 100, right? So I am just using this formula. So I am going to find out number of photons, and that would give me number of neutrons, number of neon atoms. So number of photons can be given as what is the total energy. So total energy power is actually 10, it is saying that 10 to power minus 2 joules per second, right? So in 1 second, number of photon in 1 second, if we are going to find out, so total energy in 1 second coming out is 10 raised to power minus 2 joules. And what is the energy of one photon? Okay, we will find it out. One photon. Okay, what is the energy of one photon? I will find it out here. So energy of one photon is given as h into f, and you can write it as h into c by lambda, because f is c by lambda. Okay, so if you put the values here, so number of photon will come out to be 10 raised to power minus 2 by h is 6.6 into 10 raised to power minus 34 into c is 3 into 10 raised to power 8 by lambda. So lambda has to go here, I will take it up here. So that is 6 into 10 to the power minus 7. Okay. So number of photons will come out to be so this is 10 to the power minus 2, 10 to the power minus 7, it will be 10 to the power minus 9, and here it is 10 to the power 8 and 10 to the power minus 34. So this is there is 10. So okay, I will write 10 to the power minus 9 first, and from below minus 34 plus 8, so this is minus 26, and it will come up and it will add. So 26 minus 9 is the power, and here you have 6. I will cut it with this 6, and I will raise this to 3.5 or something, and then 1 by 3.5 is almost 3, so I will say 3. Okay, so number of photons will come out to be where should I write? Okay, I will write it here. So fraction, if I am going to find out the fraction, so the fraction would be number of photon is about 3. Okay, 3, but then it has to be 25. Okay, so 25, if I am putting here 3, so then 10 raised to power 25 minus 9 is 16 by 6 into 10 to power 21. So this is 6 into 10 raised to power 21. So the fraction is coming out to be 3 by 6 is 0.5. So I will take it as 0.5 into 10 raised to power 16 minus 21 is minus 5. So our answer is fraction is 5 into 10 raised to power minus 6. So this is the fraction, percentage of neon atoms taking part in the laser action. Sorry for this cramming of the space, but in my video lectures it will keep happening. Sorry for that. Anyways, thank you.